Okay, so this is a question that I was asked about, and I thought that I've actually kind of already worked it out, and I thought that I'd take a second to sort of explain it and sort of work through how to do a question like this. So we're told he drove 50 miles to pick up his sister, and then he returned home. On the return trip, he was able to average 15 miles per hour faster than he did on the way to pick her up. If the total trip took 1 hour, then what was Jose's average speed on the return trip? Okay, so what I'm going to do here is I'm going to make a let statement, and I'm going to use an STD chart, speed, time, distance. I use STD. It's kind of silly because we remember STD from non-mathematical related things, um, and so it's an easy acronym to remember. But also speed times time equals distance. That's how I like to set it up. Um, but there's three formulas really to know here, and I'm kind of just taking a screenshot of a formula here. Speed times time, or speed equals distance over time, distance equals speed times time, or time equals speed over distance. Okay, so what I'm going to do here, I've already set this up here, so um, we're going to say that we're going to let x be Jose's speed on the way to pick up his sister. Um, so that's going to be x, and he averaged he was 15 miles per hour faster on the way back. Um, so then, x plus 15. Okay, so next what we need is what else we can work with here. So time, we don't know the time. We know that it took an hour in total, and we know that the distance in both cases was 15. Um, 15 miles. Um, a lot of 15s here. Okay, so time is it's also equal to uh, distance over speed. That's just using these formulas here. So distance over speed. Um, so if time equals distance over speed, then we can use this formula here to go, okay, 15 over x and 15 over x plus 15. Okay, so here's basically the joule that we were looking for here. And that's the formula that we can use here. So I can turn this into 15 over x um, plus 15 over x plus 15 equals 1. And there we go. We now have a formula that's all set up for us. So at this point here, it's just as simple as solving it out. So I've actually worked all this out um, just because rather than you guys watching me fumble with the equation editor, it's already there. Um, so let me explain what I did. So the first thing I did at this step here is uh, I cross or I found a common denominator, which is x plus 15. And then in order to do that, I got to multiply this x here by x plus 15. So I got to multiply this 15 here by that. Conversely, this x plus 15 is missing x, so I got to multiply this 15 by x. And then I could just cross multiply at this point because it's 1 over 1. 1 is the same thing as 1 over 1. So that just leaves us with this equation here. So basically I could just bring this up top over here and we're good. So next what we do is we simplify. If I simplify this here, it gives me 15x plus 225 plus 15x, which just works out to 30x plus 225. And over here, it's just going to become x squared plus 15x. Bring everything over to one side. Simplify gives us x squared minus 15x minus 225 equals 0. And then at this point here, we plug this into the quadratic formula. We get these two equations, which ultimately works out to negative 9.27 or 24.27. Again, quadratic formula, I'm assuming you know how to use it at this point. A quicker way of doing this, if you want to use graphing technology, which is actually how I got these numbers here, I just use the Desmos graphing calculator. I have it linked at the top of the course page. And I just can just go right in here and just sort of whip that up right here like this. Okay, so I just put it in here. I actually didn't even have to write y equals. I mean, with most of these types, you do have to do that. And then we can just kind of zoom in on our two intercepts. Right, so this is where they are. Now we know we can't have a negative number because he wasn't driving at a negative speed. That's 24.27. Okay, so what that means is that this is therefore statement's wrong. Is that it means that if he took 24.27, his speed was 24.27 miles per hour on the way there, and that means on the way back we have to add 15 to that. So thus, Jose averaged 39.27 miles per hour on the way back. And that's all there is to it. So hopefully this made some sense. I know these questions are hard. These are some of the trickiest questions that we get in advanced functions. So I kind of like them because they're kind of fun and different. And it's kind of cool to get to use some algebra to be able to solve this stuff. But at the same time, it can be a little bit frustrating at first because it's kind of like, well, how am I supposed to know this stuff? So that's why if you're taking the time to actually go through every question with a fine-tooth comb, you're going to be in great shape for the test and the assignment and eventually the final exam because you're going to know all this stuff, and that's really it's really important because, like I said, this is probably one of the more difficult sections we encounter in this entire course. All right, thanks.